Welcome. In this video, we'll conclude our examination of the while and do-while loop control structures. In the previous video, we introduced the concepts of while and do-while, explained how they operate, and gave some examples in Java. In this video, we'll provide specific applications where these loops could be of some value to you. We'll talk about input validation and provide some examples of how that can be accomplished. And we'll also talk about dealing with an unknown number of input values by using something called a sentinel value. So let's get right into this and take a look. In an interactive program, there's a conversation or dialogue going on between the application and the user. The application will request some data from the user will comply and respond with some data. In response to that, the application may then give additional instructions or give some output to the user, and the user may again be able to respond and provide additional input. One of the concerns that we have with an interactive application is whether or not the user will actually provide a legitimate or legal value. So if we request a value from the user such that it perhaps is a number within some specific range, can we be certain that the user has entered such a number? If they have not, then we need to go back and ask them to re-enter it, and will not be able to proceed in the processing until we've obtained a legitimate or legal value. This process within the program is called input validation. Let's take a look at a little example. This code begins by prompting the user, asking them to enter a value between 1 and 100. We then read the input that the user has entered, assign that to a variable called number. Then, as long as the value they've given us is not within the acceptable range, for example, we're looking for 1 to 100. If they give us a value that's less than 1, that's not permitted. Or if they give us a value greater than 100, that's not acceptable either. So as long as it falls outside of the acceptable range, we proceed to display the message that says, hey, this is a bad number, this is invalid, and prompt them once again for a number between 1 and 100. Read the value they've entered, and due to the nature of the loop, we go back to perform the test to say, is it within the range or is it outside of the range? And based upon our conclusion, we then either ask them again or we move forward. Once we have an acceptable value, we proceed to execute instructions that follow the loop. In this case, simply printing out a message that says, got a valid number. Let's take a look at an input validation routine in action. Here in this application, we've implemented this logic within a program that uses a while loop. So let's closely examine the code. We have our control variable called number, which is going to hold the user input, whatever integer the user enters. We prompt the user for a value between 1 and 10. We then read the value they've entered, assign it to our variable, and then we perform the check. Provided the number is within the range of 1 to 10, we accept it and move on. But if it's not between 1 and 10, we put out the error message, prompt again, and continue. Let's actually give this a try. Prompted for a value between 1 and 10. So of course we respond with something like 11, outside of the range. The message is displayed from within the system out print line invocation within the body of the loop. It says it's not a valid number. And then again within the body of the loop, we request another number. So now we try 0. Again, this fails. It's outside of the range. We give it one more try. We try 9. 9 is accepted as a valid number. This statement was printed outside of the loop structure. But again, we were not able to proceed beyond the loop until we had given a valid value. It's also possible to perform input validation using a do-while loop control structure. In this example, we again declare number as our control variable, and we do this outside the loop. Then the body of the loop is a bit different. On line 14, we prompt the user for our initial value. The difference here is we did not do this as a priming operation outside of the loop, but because we're performing a post-test loop, we're always going to enter the body and execute the body at least one time. Therefore, the first thing we do within the body is to request the first number to be processed. Additionally, another difference occurs with the if statement that we've included. The if statement is examining the value that the user entered to determine if it's a legal value. If it is a legal value, then we just move forward. But if it's not a legal value, we display a message informing the user that they've entered an invalid number. Then on line 20, the same test is performed, except this is the control condition for the loop. What we're doing here is testing to see whether we go back into the loop and do this all over again, or whether we exit the loop. Remember, it's a post-test, so the last thing we do is perform the inspection of the control condition to see whether we have to do it again or exit. It's the same condition, but it's being evaluated for a different purpose here. Let's take a look at this in action. So we're asked to enter a number between 1 and 10. So we'll play the game as we did last time. We'll enter 11 or outside, says it's invalid. We take another stab at it. We enter 0, also invalid. And finally, we respond with a positive number that's going to fall within the range. And this is the point at which we exit the loop. And on line 22, the message is displayed that we've given them a valid number. Let's look at the code between the two different approaches. So at the top of the display, I've given you the code that we demonstrated using a while loop to accomplish input validation. And on the bottom half, here's the code for using a do-while to perform the input validation. So you might want to take a close look and make sure you're comfortable with the differences between the two approaches. The final topic for this video involves something called a sentinel value. Suppose we need to design an algorithm that's going to do something such as computing the sum and the average of some set of values, such as a person's bowling scores. What we would like to know up front is how many such scores are going to be provided, but it's possible that information is not available to us. So what we're able to do is to somehow make a determination that when a value is entered, that it's actually a valid score, and it goes into the process of computing the sum and the average, or it's a signal to say we're all done. There's no more data coming in. The concept here, using a sentinel, is based upon the idea that there is a signal within the data, or within what would be perceived as data, saying this is not data, this is the end, a marker of some sort. The point, though, is if we think about what's going to happen, a user is going to enter a bowling score. What's a possible score? Well, they could be spectacular and score a perfect 300. They also could be horrible and score nothing. So it could be 0 to 300 would be an acceptable or valid bowling score. So the signal has to be something other than the values between 0 and 300. It has to stand out so that we cannot misinterpret it as being a legitimate score, but interpret it as this special sentinel or signal. A sentinel is also called a flag value because once it's encountered, its presence is an indication that we should terminate. It's a condition of termination. Let's take a closer look here, giving you a little flow chart to see the process. In our application, what we're going to do is declare some variables and initialize them. And we're also going to proceed to do some priming operations, such as getting the initial score, reading that from the user, and prompting them and reading that from the user. Then we get into the loop. So the sentinel value, as we'll see, is going to be read just like a score. But what happens is when we read a value, it could be a score, it could be this special sentinel signal to say we're all done. So what we're using is we're using -1 as the sentinel value. So in our loop control, the condition is interrogating what was entered. We read it into score, but we take a peek at it and say, if it's -1, then we are done. So if it's not -1, then we're going to accumulate the value, give some indication of how many things we've accumulated, increment our counter, and then proceed to get another score. Check that. If that is legitimate, if it's not equal to the sentinel, do the process again. But when it is equal to the sentinel value, then we bail out, we exit the loop, compute the average, display the result, and so on. So the value for the sentinel has to be something special that we cannot confuse with a legitimate value. And it serves again as a signal that indicates this is the end of the line. There are no more legitimate data values coming. So the loop control condition is testing specifically for the sentinel value. Now, detection of the sentinel, as we said, is a signal that the loop should terminate. I've got a program that's going to illustrate this. Let's go take a look at it. Okay, here's our program. So we've got a bowling score variable, and we've got a variable to hold the sum and the count. These are all integers, and then we've got a variable called average, which is going to be computed based upon the sum divided by the number of scores. So we have that as a double. We prepare our variables, initialize sum and count to 0. We request the first score, and we get that, and as long as the bowling score is not equal to -1, the sentinel value, then we add that bowling score to the sum, increment the count, request the next score, or notify the user -1 will be the sentinel, so that'll wrap it up. We get that, and we come back up to line 19 to interrogate the value. If it's -1, we're done. If not, we consume the value, adding it to our sum, incrementing our counter. Eventually, we get all of the data, so we display the count and the average and present that to the user. So let's go ahead and fire this up and see how it runs. Okay, we'll enter the first score. Let's say we got 150. Second time we got 160. Third time we have 145. We have 155, and that's it. We bowled 4 games. So we put a -1 as our sentinel value to signal the end of the input, and it computes the total and the average. It tells us there are 4 scores, and it computes and displays the average as 152.5. That's the basic idea of what happens here. I'll let you take one closer look at the code if you wanted to examine this. But that's the idea of the sentinel value. So the value that was received as a score was processed, but the value that was received potentially as a score, but turned out to have that special signal value of -1, the sentinel value, signal that's it, no more stuff is coming, jump out of the loop. The condition was no longer satisfied, so we continued processing beyond the loop. That's the basic idea of the sentinel, which allows us to not have to know beforehand how many actual values are going to be coming in. So we're basing it upon some kind of a signal condition. So that completes our introduction to the while and do-while loop control structures. In particular, in this video, we focused on how to use these possible applications of these 2 loop structures. So we discussed the input validation, and then we discussed working with, say, an unknown or variable quantity of input elements using a sentinel value.